So question number 1.2. Let me type the question. Okay, so question is pretty much simple. You can just read it out and anyway, you could read this red color because of my mistake. Okay, read the question. So you have to be very careful in reading the question because everything is in the language itself. And if you are able to decode the language clearly, then the question is easy. So question is clear?
Yes, sir.
Great. So go ahead and try to solve this question.
So I got the answer.
Yeah. Can you check the answer in the book itself?
Uh, yes, sir. Answer.
Yes, sir. Even I got it.
Just check the answer. So, it is purely language problem. So if you can decode the language, it's done. So what is the average value? What you are getting? Tell me, Siddhant.
Sir, I
What?
got the answer as 2V0 into 2V1 plus V2 divided by 2V1 plus 2V2 plus 2V0.
Okay, that's too much complex. Siddhant,
So
what's your answer?
it's not 2V0 in the numerator. It's 2V0 into V1 plus V2.
Like this.
Yeah, divided by V1 plus V2 plus 2V0.
V1 plus V2 plus 2V0.
Yeah.
Like
Yes, sir.
this.
Same answer.
Excellent. So this is the right answer. Very good. So can you send me solution? I would just like to confirm the way you have done. WhatsApp me your answer.
Yes.
So this was your answer, right? Okay, great. V0. Okay, great. T2 by 2, T2 by 2. Very good. Very good. Hmm. So x by 2, T1 is x by 2 by V0. Very good. Mhm. And x by 2 by V0. X by 2 equals to V1 into T by 2 and V2 into T2 by 2. I think how you got the second part, Prasant, I'm looking for your answer. In the second part, you wrote 2T2. See, the last journey is x by 2, which you traveled with V1 into T2 by 2 time and V2 into T2 by 2 time, right? This should be the question, isn't it?
So I'll first wrote T2 equals to x by 2 by V1 plus V2 and then took the 2 in the T2 side.
No, why you wrote 2T2? Because the total time is T2 only. Hmm? And why you added the velocity V1 and V2? say you traveled with V1 speed for the half of the remaining time, which is T2 by 2, which is correct. And then V2 with T2 by 2 again. And the total is X by 2. And this will give you X equals to into T2. So T2 turns out to be X by V1 plus V2. But the way you got, why you got T2, T2, I don't know. And then you just wrote X by 2 V0 and plus X by V1 plus V2. Again, that is not making sense. The reason is the time is T1 plus T2, but you have added T1 and 2 T2, right? So
Yeah.
you need to recheck, just recheck.
So, but this looks fine only, no, sir?
The answer is correct, but method is not correct. This is correct, what I just wrote. Now what she has taken is, she has taken like X by 2, and X by 2 is the remaining journey. This is T1, this is T2. Now half of the time, which could be anything, which you don't know. So T2 by 2, you travel with V1, and then T2 by 2, you travel with velocity V2. So half time is T2 by with V1, and half time is V2. So the V average is total distance, which is X, and total time is T1 plus T2. Now T1 we can write as X by 2 by V0, which is X by 2 V0, right? But the the remaining half, the X by 2, you're traveling with a distance, I mean, with a speed V1 into T2 by 2. Now this is the distance traveled with V1, and then you travel V2 for this much time. So the total distance traveled should be X by 2. This is what I have done here. And now this will give you the T2 value. And because you know T2 and T1, so you guys are substituting the right answer. Like somehow what you're substituting is correct. But the equation that you should have written is no. So now this will give you the answer. The average V equals to what you have written. Okay. Now, Shreya, what you have done is again, I don't know how you have done what you have done, but these are not the right question. So your question 1 is correct. Question 2 is having no meaning right now. And then the third equation is correct. The average definition is correct. So you need to modify the second equation the way you have written. Okay. Chidand, what you did?
So similar only. So should I send?
Yeah, just let me see. Similar to what Shreya, my Prashansa did. Okay, no, you don't know what she did. Just send me. Let me check. No, this is still not correct. You have to explain how you got the second question. That is missing entirely. Okay, okay, okay.
So your total distance I took as 2D.
Yeah, yeah, that is what you have written is again incorrect. If you're taking half time as T and T, okay, so the total time will be 2T, right?
Yes, sir.
So the average speed is total distance upon total time, which is 2D upon D by V naught plus 2t, which is 2d by v1 plus v2, right? Do you see the mistake here? In the v average formula, which you have written 2d upon the second term in the denominator should have been 2d by, right? You are adding 2t, isn't it? The total time is how much? D by v naught plus 2t, isn't it? In the denominator, see, this is what you have written. Let me rewrite. This is what you have written, right?
Yes, sir.
Now, what is the total time of journey? This plus 2t, no?
Yes, sir. That 2T I wrote as. Achha,
Yeah, you can see the mistake.
okay, sir.
So that 2t becomes 2d by v1 plus v2. And now this will give you the answer which is desirable. So somehow you have made a calculation mistake and still you wrote the right answer. That's very interesting that, you know, after making so many mistakes, you are getting the right answer. And in fact, everyone is getting the right answer. So yeah, I was surprised at how everyone is getting the right answer with very non-conventional way of solving.
No, sir. Actually, when I did in rough, I got the right answer. But
Yeah.
now, when you asked to send the pic, so I just did it fair.
Forgot. Okay. Okay. Understood. Now tell me, Prashansa and like, did you get how to do it? Have you understood this part?
Yes, sir.
Okay, so be very careful with the calculation, but good effort. You all have put a good effort here, and I'm pretty much glad. Okay. Now, after doing the average calculation, I'll just show you something interesting. Solving kinematics is like, you know, solving puzzles. So if you love puzzle, if you have loved it in your childhood, you will definitely love solving kinematics. It is not physics. Don't say this as physics. It's like we have done in the like in junior classes, class 6 and 7, linear equation, time and distance problem. So these kinematical questions are like similar to that, and we just need to interpret the language into mathematical symbols. And if we are able to do so, we are definitely going to get the right answer. So kinematics is just to enhance your calculation ability, your ability to write the equations, basic linear equations, and just manipulating the equations, getting the desired answer. So these are like kind of practice which will help you eventually throughout physics and also in mathematics in other part of science also. Okay. So let me give you a very nice question. So if I give you, so a person goes from, let's say, A to B. So you go from A to B. And you travel F1 fraction. Like, I mean, I'm not guys saying half or 1/4 or 3/4. What I'm saying, if you travel F1 fraction of the total distance with speed V1, F2 fraction with V2, and F3 with V3, and remaining. Remaining is what? If I say remaining, so remaining means, so sum of fraction is always 1, right? If you divide any journey into fraction, then sum of all fraction must be equal to 1, right?
Yes, sir.
So the remaining is always 1 minus the fraction which you have known to till this point. Okay. So this is how you can do it. And what I'm saying is that you travel the first F1 fraction with V1, F2 fraction with V2, F3 with V3, and so on. So what is the average velocity of the journey? Okay. So let's say I have taken only 4 fractions. And in fraction, if I give you 3, the fourth you can find. If I say there are 5 fractions, then if I give you 4, the fifth you can find using the sum rule of fraction. The sum of all fraction must be 1. So the idea is this entire thing can be written in a single line by a formula V average 1 upon V average equals to fraction upon velocity summation. That's a simple rule that you can always remember. Will save your time in examination if you know exact fraction. Now the question which we just solved is not based on this. There the time was also involved. But if the velocities are given in fraction of total, by writing this formula, you can get the answer directly. Okay. Now, you can of course prove it or derive it. Let me demonstrate by the simple question that we have solved in the past. So when you go from A to B, and if you travel half the distance with V1 and half with V2, so what fraction you travel with V1? 1 by 2. And what fraction you travel with V2? 1 by 2. So what should be the answer? 1 by V average equals to 1 by 2 by V1 plus 1 by 2 by V2. That's simple. We're writing the fraction. And this is the answer. So you can also write as 1 by V1 plus 1 by V2. And if you rearrange, you'll get the answer. So in fact, you can extend this to any number of fractions. So let's say if I divide a journey into 3 parts. So you travel first half with V1, then half of half, that is the 1/4 with V2, and again 1/4 with V3. So what will be the average values? Can we write directly what is the V average? Tell me the answer. So 1 upon V average will be equals to
1 by 2 V1 plus 1 by 4 V2 plus 1 by 4 V2.
correct. So you can see it's pretty easy to get the answer in one line. So given a fraction, no need to worry, do the calculation. You can just do this directly and you will get the answer. So you can see this as the special trick. So it will save your time in the examination. No need to worry much. And only use when we know the fractional distances are given. Okay. That's pretty much easy.
Can we use this when they have given a fraction of time?
No, when time is given, then we can't use. We can use for the distance actually. If I know the distance and the fraction, then I can use it. In time, you can find the fraction. That's not an issue. So let's say in the previous question which you solved, you wrote the remaining half as V1 T2 by 2 plus V2 T2 by 2, right?
Yes.
And when you solved, you got T2 equals to X by. So the fraction is, the first fraction is V1 T2 by 2 upon X by 2. This is the fraction, isn't it? This is what you traveled out of this distance, correct?
Yes, sir.
So you have to find the fraction, which is like, again, it's a cumbersome job. So V1 T2. So V1 by this is V1 T2 by X basically, and V1 by X into T2, which is X by. So the first fraction turns out to be V1 by V1 plus V2. So definitely the second fraction will be V2 by. And therefore the answer will be 1 by V average is 1 by 2 of V naught, because the first half you travel with this one. Then first fraction with V1. So if I divide the F1 by V1, I'll get the very interesting answer. F1 by V1 is how much? And similarly, what is F2 by V2? Same answer, correct? So this turns out to be something very different. Am I correct? Oh, sorry. This is the, oh, my bad. The total distance is X. I need to modify a bit here. The total distance is X. We are talking about the net fraction, huh? Right? So this turns out to be by 2, right? The 2 will come here. Anyway. And I missed the 2 here. So the 2 will come here and the 2 will come here. What will happen? This will become, correct?
Yes, sir.
And you can see this is the same answer. The V average turns out to be. So whatever is given, if you can find the fraction, you can use this formula with ease. So generally, we should employ this if it is really complex and we want to save time. But most of the cases you can do it with ease with simple calculation. Okay. So let's say if someone is asking you, okay, if a journey is traveled into 5 equal parts, so the 1 by 5 will come everywhere, right? 1/5 1 V1, 1/5 V2, 1/5 V3, 1/5 V4, 1/5 V5. So the answer will become 5 by V average equals to 1 by V1, 1 by V2, and so on. So if a journey is traveled into n equal intervals, I don't know which number. So if a journey is divided into n parts, n equal distances, and if you complete the each distance with a velocity v1, v2, and v3, so the 1/nth of the distance, let's say if the d is the distance, you travel with v1, then d by n you travel with v2, and so on, and the last d by n you travel with vn. So you can directly write the, because the fraction here is 1 by n, you can write n by v average because you can take comma. I hope this is clear.
Yes, sir.
So this is pretty much obvious. So now we are going to start the uniformly accelerated motion. So we'll first do it horizontally, then we'll do it vertically. So we are going to learn in a horizontal plane first. Now, when I say uniformly accelerated motion, does it mean uniform motion? Yes or no? Does it mean uniform motion?
No, sir.
Because acceleration means change of velocity, which means the state of motion is changing continuously. So the presence of acceleration means the state of motion is changing continuously, which means it is non-uniform motion. So the word uniformly means the change is uniform. The way we have been changing the velocity, that the change is constant. So every second when you say how you say acceleration, let's say you say acceleration 2 meter per second square. Now what does it mean? It means 2 meter per second per second. So the idea is, this is saying that you can change the velocity by 2 meter per second every second. So every instant you're going to change by this value. So that's why you say uniformly accelerated. But let's say in the first second you change by 2 meter per second, but in this next second you change by 3, next you change by 4, next you change by 5. So such kind of motion is called non-uniformly accelerated motion. But once it is accelerated, it is always non-uniform motion. So when we talk about motion, it is always non-uniform. So uniformly accelerated means the change is going to be same every second. So in simple terms, the acceleration is going to be constant. That is the meaning, but it is not the uniform motion. I hope this is clear.
Yes, sir.
So it is non-uniform motion, and one should not be confused between this and the uniform motion. So in uniformly accelerated motion, if I make a equals to 0, it becomes uniform motion. Okay. So if a is 0, so a is 0, I would say a vector is 0, because when I say a is 0, it means I'm saying the magnitude is 0. If I say a vector is 0, it means it is 0. So it is neither changing the direction nor the magnitude. So if a is 0, then it is called uniform motion. If a is non-zero, it is called non-uniform motion. In one dimension, since direction is not the issue, so in one dimension, the a is non-zero, is accelerated, you can say, or non-uniform motion. Just one. Now, most of the one dimension accelerated motion we are going to solve by the graphical method. So today we are going to solve those questions which we generally solve by mathematical method or analytical method. All the challenging questions that you will see, we can easily solve using the graphical method. So we'll see the graphical method later on. Right now we are going to solve some of the basic problem of one dimension. So when A is constant, we call uniformly accelerated motion. Change the color. And therefore we can use the kinematical equation. So what are the kinematical equations which we have seen? V equals to U plus AT, we can use this. And we have derived this in the dy by dx as rate measured, if you remember. The next one was S equals to, am I audible, guys?
Yes, sir.
But there is very interesting one. The S we can also write as, if you rearrange, and this formula is more useful at times. So if I take LCM 2ut plus AT square by 2, which you can write as, we can take T common. So what you get is 2u plus AT. And the 2u we can write as u plus AT, because I'm going to take this as common. But u plus AT itself is called V, right? So this formula is pretty much interesting. Why? Because if you know the initial and the final velocity for uniformly accelerated motion, so it is known that motion is uniform. It is known that motion is uniform, but you know the initial and final velocity. You can find the displacement directly by using the formula initial plus final by 2 into T, which is also known as the average. Why? Because average speed is defined as total distance from total time. So this will give you the answer S by T equals to U plus V by 2. And this is very, very important to you to remember that in case of uniformly accelerated motion, the average speed can also be determined by taking the average of initial and final. You can say taking the arithmetic mean of initial velocity and the final velocity. Okay. So only for uniformly accelerated motion, the average velocity is also equals to the arithmetic mean of initial and final velocity. Is this clear?
Yes, sir.
So don't use otherwise. It is very much particular to this situation, which is called uniformly accelerated motion. So this formula is much more important than this formula. Now the benefit is the first formula of displacement involves acceleration, but the second involves the the velocity only. And many times you will be knowing the initial and the final velocity. You can use this formula to get the answer directly. So there is a third definition that the displacement we can also write as average velocity into time. So for uniformly accelerated motion, the distance is average velocity into time, not the instantaneous velocity. It is the average velocity into time is the displacement. So if you know the average, multiply by the time, you get the total displacement. That's pretty much obvious also. Is this clear, guys? How we are writing these equations?
Yes, sir.
So now, now more than the equation, you need to understand that which equation is apt in a given situation. Okay. And for that, you need to keep your mind open. Okay, that in a situation when the motion is uniformly accelerated, when you know the initial and the final, then these formulas are doing wonders, and you can find the answer without using acceleration. So many times acceleration will not be given, rather it will be mentioned that it is assumed the motion to be uniformly accelerated. assume the motion to be uniformly accelerated. Assume the motion to be uniformly accelerated. This line will tell you, okay, you can use the kinematical equation. But it doesn't mean that every time you will be given the acceleration. Of course, you can find using the u and v. If u is given, v is given, you can find the acceleration. But many times you can do without acceleration. And the third equation, which we are very much famous and known to us. So v square, it is this equation only talks about the magnitude of initial and final in terms of displacement. So v square is u square plus 2as, or many books you will see that v square minus u square by 2 is as, or yes, you can also write as v square minus u square by 2a, which you can write as v minus u into v plus u by 2a. And it is pretty much the same thing. If you look carefully, this is the v average, the second term, correct?
Yes, sir.
And the first term is time actually. Do you realize this? V equals 2 plus 80.
Yes, sir.
So what is time here? V minus u by a is equal to 2. So all will boil down to the same equation. So S is V average into time, and V average is V plus U by 2, and time is. So you can derive in a reverse order also by writing the V average into time. V average, we write V plus U by 2. And I'm writing just to show you that, okay, these are the manipulations that you should be familiar with, so that when you solve the question, then these manipulations should come to your mind naturally or instantly. So we are going to solve a very challenging problem, but with this acquired knowledge, this should not be challenging to you at all. So this is the example. The question is, so a person goes from A to B with uniform acceleration. So what is given to you that these are 3 intervals, and the average of this interval is given V1. Now remember, V1, V2 represents the average, not the velocity. So the question is, what will be the ratio of V2 minus V1 upon V3 minus V2? And this ratio will come in terms of T1, T2, T3 for sure. So you have to express the answer in terms of T1, T2, and T3. So this is what? Okay. What is given that the motion is uniform. So take your time. This is of course a challenging problem, not an easy one. And based on the result, we do have some more questions. Question is clear? So for the first time interval T1, your average turns out to be V1. For the next interval T2, the average turns out to be V2. And the next T3, the average is V3. So you have to use the kinematical equation, use the definition, and assume variables if you need. If you think that you need to assume some variables, do assume and try to solve this question. First of all, tell me, question is clear or not?
Yes, sir.
Great. Please go ahead.
Sir, is the answer 1?
Got the answer?
Sir, is the answer 1?
Now, how it could be 1? Because we have to find the answer in terms of T1, T2, T3. Again, let me tell you, V1 represents the average velocity of the duration T1. So you can assume the velocity at the end, right? Some value. Let me give you some hint here. Assume velocity here U, here V dash, V double S, and V. That's easy way. So if you know the velocity of the end, and if you know the time, and if the acceleration is constant, we can write the u and v dash relation, isn't it? So what is v1, by the way? V1 is how much? The v1 is the average of the t1. So v1 we can rewrite as, tell me guys, in terms of the new variables which I have assumed, u, v dash, v double dash, v, how to write v1? Siddhant, tell me. The average velocity for any uniformly accelerated motion is the arithmetic mean of the initial and the final velocity. Once again,
Yes, sir.
the average velocity of any uniformly accelerated motion is the arithmetic mean of initial and the final velocity. So what we should write here? Tell me.
U
U
plus
plus
v dash by
V1.
U plus v
v dash
dash by 2. Very good. So similarly, can you write v2 and v3? So what is v2?
V dash plus V double dash by 2.
So what is v3?
V double dash plus V by.
Now, what you were supposed to do is just replace v1, v2, v3 in the equation. Because once you replace, you will get the end velocity, and we can use the kinematical equation for the end velocity to get the relationship. So can you do further? I have given you the first hint. From here, you should be able to proceed and get the answer. If not, then I'll give you the second hint. So try from here. Okay, the first step is substitute the value, and then think about what you can do using the kinematical equation, given that acceleration is constant. So if a is constant, we can do a lot of things. So please try this. See, these are not easy questions. These are definitely the, you can say, the most challenging problem you will come across in kinematics. And it looks pretty simple. It looks like, okay, it's just plain question, but it requires some more idea. So from here, please proceed. Give a second chance. I'm sure all of you will get the answer.
So the answer is coming in terms of V and U.
The answer will come eventually in terms of T1, T2, T3, like something in terms of T only. So once you substitute, what you get after the first step, what are you getting here? Tell me.
V dash V double dash minus U by V minus V dash.
Now, can you write the relationship between V double dash and U directly from kinematical equation? So if you take the entire interval from here to here, what will be the relationship? V double dash equals to U plus A into
T1 plus T2.
So V double dash minus V double dash minus U is how much? Correct?
yes, sir.
Yes, sir.
Similarly, V minus V dash, what we can write? A into, and you can clearly see this A will cancel out. So the answer we got in terms of the known variables, which is T1 plus T2 upon T2 plus T3. Is this clear, guys? Yes or no?
Yes.
Yes, sir.
I hope this makes sense to you. Okay. So many times when you are driving a car and you apply brake, okay, so eventually you will come to rest. And coming to rest is very interesting scenario, because coming to rest means you know the final velocity. And what is the final velocity when you come to rest?
0.
0. So if you know the initial velocity of your car, you applied the brake, assuming the brake is creating uniform retardation. So uniform retardation is also called uniformly accelerated motion only. But here the acceleration is negative in value, which means you're slowing down. So whether it is uniformly accelerated or uniformly retarded, in both cases we can apply the kinematical equation with the change of sign. So we put A as minus value because in the formula we have acceleration. So the way we substitute the retardation in the formula of acceleration is by changing the sign. Okay. So when you apply the brake and if you come to rest, you know that how much time you will take to come to rest. So let's say if you know the time taken to come to rest, you can directly find the displacement from the time you applied the brake till it comes to rest, how much you traveled. Okay. So let's say there is a wall. Okay. And the wall is at a distance d. The wall may be like a standing elephant on the road, or maybe a pillar which you don't see generally. So let's say during the road construction, they erect some pillar, temporary pillar, and in the night we don't realize that there is a pillar until we come really close and we see. So they put reflector to prevent the collision or accident. But let's say in some scenario there is no reflector and you fail to see it. So someone is driving a car, and this is a very dangerous situation, and that is leading to a lot of road accident across country. So someone is driving a car, and the velocity with which you are driving the car is v0. And when you are at a distance d from the wall, you realize there is a wall, there is a pillar, or there is some obstacle. The obstacle may be a car which is abandoned on the road, which you don't see. Maybe the car had the breakdown on the road and someone has left it there on a highway. So these situations are very much practical. It happens, and even we all have experienced. If you have driven on a highway, you must have gone through such situation as well. So driving on a highway requires a lot of presence of mind and alertness, because these situations are not welcome, but it generally occurs. So let's say d is the distance at which you realize there is a wall. So you will apply brake to stop it. Of course, you will not apply very hard brake, otherwise it will skid. That could lead to again another accident. But you will apply brake to slow it down. So let's say the car is capable of creating a retardation of AR. So AR is representing the retardation, which means once you apply the brake, it will slow down at a certain rate, and we are assuming this to be constant. Why? Because we are trying to use the kinematical equation in order to solve the question. Okay. So when you realize, okay, you will apply the brake and you will try to stop it before it. So what is the minimum distance D? I want to know what is the D minimum which I need in order to stop it without hitting the wall. So find D minimum in order to prevent collision. What is known to you? Your initial speed of car is V0 and the brake can create the maximum retardation AR. So the minimum D means till you are about to hit the wall, you must come to rest. So velocity here must be 0. So if you come to rest just before the wall, the collision will be prevented and so the accident. So question is, what is the minimum D that should be? Okay, the safe distance, or this is also known as the braking distance. Now braking distance is a very important concept. So when you drive, you must understand that, okay, the moment you apply the brake, the car will not stop there. So before it will stop or slow down, it will travel some distance. So for preventing collision, the braking distance should be known to you in advance. And depending on the car configuration, the braking distance varies. And also it varies with the speed. So generally, if you read the specification of a car, they do mention the braking distance, that it takes maybe 100 meters to stop. Okay, if it is a really good car, and 100 meter to stop if the speed is 80 kilometer per hour, or if it is 100 kilometer per hour, then it will take slightly more distance. If it is 150 kilometer per hour, then it will take, in fact, 500 meter to stop also. Now on a journey, the 500 meter is nothing. It's a very small distance. The half a kilometer is not a big deal. So when car is moving at a speed of 150 kilometer per hour, then 500 meter is something which you will not realize. It's so small. In case of Ferrari, I mean, they need extreme braking distance. I mean, they need as small as possible the braking distance, because they move at a tremendous speed of 300 kilometer per hour and something more than that also. So braking distance is a very, very important concept, and this helps us in determining that where we must apply the brake in order to prevent the collision. We cannot expect a car or any moving vehicle to come to rest immediately. If it is moving really slow, then it will come to rest, but it will travel some distance. So that comes to the driving experience, definitely. That what is the right way to apply the brake? Take a precaution, apply as early as possible for safer driving experience. Anyway, so what is the answer? What is given to you? AR, and it's a pretty much a simple equation. So if you look carefully, what is known to you? Initial velocity, final velocity, acceleration. And what we're looking for? Displacement, right? So which formula is the formula which relates the initial final with the displacement? Out of 3 kinematical question, tell me guys.
S equals to UT plus RT.
Now you don't know time here, right? See, there is nowhere I have mentioned time, isn't it? Have I?
So the last equation, d
The
square
last,
equals
correct.
to e square plus 2.
Correct. Use the last equation and get your answer. That's it. But what is AR here? Retardation. So when we substitute in a formula which talks about acceleration, we put with minus sign. Is this clear? Is this clear, Prashant? Tell me, Siddhant,
Yes,
Shreya,
sir.
Yes.
understood, no?
So is the answer V naught square by 2AI?
Correct. That's the right answer. So you write 0 square, the final. So we are going to use the third equation, V square equals to U square plus 2AS. Always remember A represents acceleration. So if you want to substitute retardation, put with minus one. That's a simple thing. So U is here V naught. 2 is 2. What is A? A is minus here. And S is D minimum. You want to know the D minimum. So let me put a heading, braking distance. Something which is very, common. So if you know the braking power of a car, the maximum retardation it can develop, and if you know the initial speed, you can easily determine the braking distance. And if the specification is, let's say, 100 meter, you can always keep it as 125 meter, because the specification is for the expert driver. So as a beginner, if someone is starting a driving, they should not take the risk and apply slow braking, but much before you expect. So now this is not a difficult question, just the terminologies are very interesting, braking distance and all. Sometimes the idea of, when you drive a car on a highway, you see that nothing is coming as an obstacle, but what you see is that you're trying to move, you're driving your car at a high speed, but the car in front of you is moving very slow. So maybe you're driving a Honda City and the car in front of you is a Tata Nano. Even the Nano will try, it cannot drive more than certain speed. So the situation is very much common, and we'll learn how to prevent collision in such scenario. So this is the highway, okay, and we have two cars. One is small car, and other is a high speed car. Let me design this car. So I'll try to make a designer car. Okay. So you can see there are two cars, and the car behind is moving really fast. Maybe this is a Ferrari. So this is moving with velocity v2, and the car in front of you. So here we are assuming that this car is moving with velocity v1, and this is constant. You're not going to change. So the person in front of you is not aware that someone is coming, and so he will not accelerate. He will just move with its own velocity. The car behind, okay, when you're driving very fast, and then suddenly you realize that, okay, the car in front of you is moving slow, and it's a single lane road, so you cannot overtake. So let's say the overtake is prevented, or it is illegal to overtake. Okay, so what option you have to prevent the collision? What option do you have to prevent the collision? Tell me.
Stop before they come in contact.
Should you apply the brake to come to rest, or is it okay to not be at rest, just move with some speed? What do you think?
Apply the brake and control.
So for how long you will apply the brake? Forever?
Sir, till V2 becomes equal to V1 or less
Very
than
good. Excellent. You can drive car safely. See the here there is no obstacle. It is a moving obstacle. You can say this is moving obstacle. So if you retard your velocity till the velocity of the obstacle, both will move together but without colliding. So the moment you reach just behind the obstacle, by that time your velocity should be equal to that of the obstacle. And once you achieve the velocity of the front car, your job is done. So you're not supposed to retard till zero. Rather, now this is the situation in which you have to retard till the velocity of the obstacle. Now here, the front car is your obstacle. Do you realize this? Yes or no? Do you realize this, guys? So how many of you realize that the V2 should be reduced to V1 only, not 0?
Yes, sir.
Prashansa and Shreya. So do you want to drive car in future? Yes or no? Or will you keep only driver? Prashansa will tell me. So do you want to drive in future? Yes or no?
Yes, sir.
So you have to learn kinematics to be very good driver. So as a driver of the rear car, let's say you are the driver of the rear car and you see a car in front of you, which is not moving as fast as you. So basically V2 is more than V1. If you continue to move with your velocity, you will collide with the front car. Now that is what you have to prevent. The front car is moving without changing the velocity, so it's moving with constant velocity. But your car can generate a retardation AR. So I'm assuming that AR is the retardation of the rear car. Okay. Retardation that can be developed by rear car. These are very much live examples. We all do on a day-to-day basis without realizing we are doing all this. So to prevent the collision, what should happen? The rear car must reduce the velocity till the velocity of the front car. Yes or no? Tell me. Hello. Tell me, guys. You guys are not
So
responding.
can you repeat?
To prevent the collision, the rear car must apply the brake to reduce its velocity from V2 to 0 or V1. That's the question.
To V1.
Very good. So we are trying to prevent collision on the highway. Okay. That's why I said kinematics is like a real life situation, and you just need to understand the scenario. If you are able to understand the scenario, you can solve the question. So what you need to understand that the front car is moving with constant velocity, and the rear car is moving with also constant velocity, but at high speed. And because the headlight of a car cannot let you see far away, So you can only see up to certain range. And the moment the front car will come in your range, you will realize that there's a car. Okay. So here's the scenario. Let me just do something more interesting. So this is the headlight of the car. And the moment the front car comes in the range of the headlight of the rear car, you realize that, okay, oh my God, now there is a car and you need to prevent the collision. So at this instant, when the separation is D, you realize that there's a car in front of you. Okay. So again, the same question is, what is the D minimum required to prevent the collision? Find the, so whether the collision will be prevented or not, we can decide. Okay. And imagine this simple calculation is so powerful that when you're driving a car, we can code this into a software. The camera of the car will see the front car and it will apply the brake automatically as per the calculation so that the collision is prevented. And this is exactly done by the automatic cars like Tesla cars. So they use the kinematic equation extensively, and of course with variable acceleration. So the way they have designed their braking system, they know that how much distance it will take to stop the car. With varying speed, the distance will change, and all these are now automated in a software code actually. And the camera will take the input of the distance and all. So with the help of simple laser camera with laser light, so what they do is they throw the laser which hits the front car, comes back, and that is what how they realize the distance. And all these processes are like automated, and they do it internal calculation on a software which gives the instruction to the car, and brakes are applied directly. So these automation uses the basic rules of kinematics. So to design the high-end cars, what we need to do is use the simple physics, laws of physics, put into the equation, put into the software code, the machine will take care of itself. Okay. So this is how we design. So it's good to know the basic of kinematics. Okay, it is very useful everywhere. So find the minimum distance, minimum D in order to prevent collision. Of course, we talk about the minimum, maximum is no minimum, so we talk about minimum. Is the question clear to you, all of you? First of all, tell me guys, is the question clear?
Yes.
Right. So if the question is clear, think about how you're going to solve. Take your effort. It's just a manipulation. You can do something. And we have to assume here uniform retardation. Okay. Rest is your common sense applied. Tell me guys.
What is the answer? V1 square minus V2 square by 2A.
Slightly interesting. This is not the answer, but something similar to that. It's not easy. Because in the obstacle case, the D was constant, but as you slow down, the front car will also move, right? So by the time your speed is V1, you will be exactly behind the front car, which is not D away, right? It will be D plus something, isn't it? So you have to first find the time T that will give you the answer. So try this out. I'll solve later on. Again, it's just a puzzle. You know the kinematic equation, it's just a puzzle. Okay. Solve the puzzle, you get the answer. So are you guys going to try this question? Siddhant,
Yes, sir.
you want to try?
Yes, I am trying.
Yeah, very good. So Prashansa and Share, please try this question. These all skills are required to, be a good driver.
So, in what terms should we get the answer?
In terms of V1, V2, and AR. We have just three parameters given to us, V1, V2, and AR.
So I'm getting the answer as V2 minus V1 whole square by 2A.
That's the right answer. Who's getting this answer? Prashansa.
Yes, sir.
That's the right answer. So send me the solution. I would like to see what you did.
Yes.
Very good. That's the right answer. And right approach also. No, Siddhant, this is not the answer. You can see this answer is V2 minus V1 whole square by 2a by 2a. Okay. Just a minute. So what you did? No, no, this is wrong. Your answer is you made a calculation mistake actually. Just to check the second line.
Yes, sir, I think I understood.
Okay, so there are many ways of solving this question. I'll just show you one or two ways. See how to approach. But since you wrote the right answer, but the approach is again similar. I mean, it is not accurate. What you need to realize that the car is not at rest, so the displacement of the first car is not d. It is certainly more than d, right? Do you realize this? When the V2 will come to V1, what do you think? The distance traveled by the rear car is d or more than d? D is the moment when you realize. Then you apply the brake, the front car will keep on moving, isn't it? So when you will reach the rear side of the front car, the distance you will travel is more than d or less than d or equal to d?
More than me.
More than d. Are you guys able to realize this? Probably no. So see the car, let's say car number 2 and car number 1. The 2 is here, the 1 is here. The moment you realize this is d, so I'm taking the back of the front car as dot and from in the front of the rear car as the dot. The moment they come closer to each other or the moment they become one point, the front car will be ahead. So let's say they come close to each other at time t, and in time t, the front car will travel how much? So imagine this event happens after time t, and so the front car will travel v1t. So what is the displacement of the second car? To come next to each other, how much the rear car will travel, guys? Tell me. The rear car will travel how much? See, the rear car has gone from here to here, no?
D plus V1T.
D plus V1T. But S2 now the formula which you have written, S2 you can write in terms of T. How to write S2? The S2 will be equals to S2 will be equals to how much? UT, that is V2T plus half A t square, because in the same time, when front travels v1t, the rear travels d plus v1t, but the formula for the S2 is, because the second car is retarding the displacement, we can write by the second kinematical equation ut plus half t square, and this must be equal to d plus v1. Is this clear? So if you rearrange, how you can rearrange? So you can write d plus v1t minus v2t plus art square by 2 equals to 0. So you are getting art square by 2 minus, because v2 is more than v2 minus v1 into t, plus d equals to 0. So I can take LCM twice v2 minus v1 plus 2d, and this is the, what is this? A quadratic in time t. So if we assume that after time t they meet, this is the quadratic we are getting. So this is the condition of meeting. So I write condition of collision, because I'm saying they are meeting, it means they are colliding. So condition of collision is that the rear car must travel d plus v1t to collide with the front car. That's simple. And from the condition of collision, you got this equation. So when we solve a quadratic, we should get the real answer. Okay. To prevent the collision, we have to get no answer, no real answer. So tell me guys, when a given quadratic will give you no real answer? Tell me. This equation will have no answer or no real answer when it is possible?
When the roots are imaginary.
Correct. So to prevent collision, the roots must not be real. That is, the discriminant must be
Less than 0.
negative. So b square minus 4ac must be negative. What is b here? B is minus 2 v2 minus v1. So if we square it, what we get? 4 times. And what is a here? The a here is luckily AR. And what is C here? C is today. So this 4 will get cancelled out. So what you get is 2 ARD is more than v2 minus v1 whole square. So D is more than. So the minimum that we can think of, because D is always more than or this value. So numerically the minimum we can take as the other method we will see in the chapter of relative motion. Okay. So right now we can do it by the simple. So these are basically your chasing problem. Is this clear? How to approach a problem? So again, this is a challenging problem. These all are very, typically known problem. And this is from Resnick and Halliday book. Very old problem. So this was published way back in 1960 or before. So roughly you're solving 82-year-old problem. In fact, more than that. Okay.
Sir, I have a doubt.
Yeah.
Sir, instead of involving t, can we use v square is equal to u square plus 2a, that formula?
That we can use in a relative context only, because here the displacement of the second car is not d, it is more than d, right? And the way you have solved, you have taken the displacement of the second car as d in answer, right?
Yes.
I can see the solution. And Prasansa did the same. She took the displacement. In fact, there is some calculation error in the third step, and she got the answer. So yes, that is not the answer. Yes, tell me. So that is not possible. Do you realize why it is not possible?
No, sir, I didn't understand.
See, the rear car is traveling more than d, right? So if you use v square equals to u square plus 2s, so the s from this equation will give you what? The
Like if we
displacement.
find s for both vehicles and then add up.
No, this s cannot be for both, no, because the front car is moving with constant velocity. The rear car is decelerating. So how can they have same displacement? Is it possible?
No, sir.
One is moving with constant speed, other is decelerating. How it is possible to have same displacement at the same time? Is it possible?
No, sir.
Okay. Just a moment. Tell me if you have any doubt or like any confusion in this question. Siddhant, do you have any doubt now?
No, sir.
Okay. So when you will learn the concepts of relative motion, so there the d is called the relative displacement, and we write this as so you write a v square equals to, I mean, the way we write is v square equals to u square plus 2as. The chapter of relative says that v relative whole square is u relative whole square plus 2 into a relative into s relative. So if we use this relative formula, then it's pretty easy, because eventually when you move with same speed as the front car, the relative velocity in the final case will be 0. Do you realize this? If you and the car in front of you both moving with same speed, so relatively they are not moving, isn't it?
Yes.
So that becomes 0 square. The initial is v2 minus v1 whole square, and a relative is a2 minus a1. So I will add a2 minus a1, because the rear car will have access in minus a, the front car will have access in 0. and the S relative will become D minus 0. Okay. So that is how we get the answer in one line. And you can see this is the answer. This is A. But this is for the chapter of relative motion. Till that time, you can wait. Or if you have understood the method of writing relative, you can get the answer from here as well. All right.
Yes, sir.
Okay. So for every question, see, I mean, what I want is that you should learn the fundamental way of solving every question. And once you have mastered the fundamental, you will have a lot of tricks to solve. But I never encourage to learn the trick first. The trick is for the stage when you have matured enough to understand the fundamental and you have mastered the comprehensive way of solving. Then the trick will help you in solving in less time, but never practice trick in the very beginning. That is dangerous. It will take away your calculation ability. So what I will encourage is solve with basic and wait till the end. At the end of this chapter, you will learn lots of trick and lots of advanced. In fact, not advanced. It's a very fundamental way, which looks advanced. Okay. So most of the question you can solve in one line or mentally, and we'll see that how to solve those things. Okay, so let's solve some more chasing problem. So in most of the Bollywood movies, let's say this is the police jeep which is at rest, and a thief is snatching someone's wallet and running away on a motorbike. This is a very common theme of old Bollywood movies. Okay. So the police car is at rest, and the person on the bike is driving at full speed. And now it is crossing the point at which the jeep is standing with velocity v0. So this is the thief. So let's call 40420. This is police. Let's call 100. And the moment the man crossing the jeep, the police starts the jeep, and it starts with constant acceleration A. And imagine the jeep is continuously accelerating till it is going to catch the. So right now the car is at rest, but the biker is having the velocity v0. So at that instant, who will be going ahead? The jeep or the biker? Who will go ahead?
The biker.
The bike. But the police will accelerate, so its velocity will keep on increasing. Okay. So a time will come when the acceleration will increase the velocity of the jeep more than v0. And once you are moving faster than the biker, eventually will catch. Yes or no?
Yes, sir.
So eventually, let's say you will catch somewhere here. So here, the biker and the police will be again parallel to each other. So initially, the biker will go ahead and the jeep will be there only. But now, the police is in fact having velocity more than biker. This is still v0. This v is actually more than v0. And now you can see they are parallel to each other. It means the chasing has been done. And this displacement, again, there is a very nice name in everything in kinematics. This is called chasing distance. So given A of the police car and V not of the biker, can you find the chasing distance S? or let's call DCH. It looks nice. So what is the chasing distance, guys? So if I call this as t equals to 0, this is t equals to t. So before you find the distance, find the time first. And how to find the time? So you can clearly see the displacement of the police jeep must be same as that of the biker to catch. Yes or no? This is how you're going to catch. Yes or no? Tell me.
Yes, sir.
You begin at same position. To catch, you must be coming to the same position. No? So the catching or chasing problem says that the position must be same. That is logical. Yeah. For catching, the position must be same. Yes or no? Tell me, guys, everyone.
Yes, sir.
How you catch? By the at the same position. No? So when police and thief will catch each other, I mean, like of course, when the police will catch the thief, the geographical location will be same, right?
Yes, sir.
Every chasing problem will have the equating the coordinate. In this case, we are talking about the equating the displacement. Why? Because they are traveling same displacement, because they begin at the same position. So to solve this, what you will do? You will add the displacement of the police and the thief, and you will equate it. You will get the t. So how much is t coming? Tell me. So in time t, what is the displacement of the biker? Displacement of the thief, let me call S420 is same as S100, right? But the formula that we need to use is different. No? The biker will have constant velocity. So what is the displacement for uniform motion, guys? S equals to
UT plus half AT square.
but A is 0, no? For uniform motion. If velocity is constant, so there is no acceleration, right? So for biker, there is no acceleration, isn't it?
Yes, sir.
So what you will add? Only Vt, no? V not T.
Yes, sir. We not.
There is no acceleration. What about the jeep, the police?
UT plus half AT square.
But what is U here? What is the initial velocity of the jeep?
V.
Initial velocity of the jeep. The jeep starts from rest, no?
To 0.
The police jeep was standing there, so the initial velocity of the jeep is 0, right?
Yes, sir.
So UT plus half AT square, because U is 0, it's half AT square, right? So V naught T is half AT square. So what is T, guys? T is 2 V naught. So the chasing distance we can write as V naught T, or you can write half AT square, it's the same thing. So substitute the value T is how much? 2 V naught by A. You could have used other formula, half AT square, it will give you the same answer. Okay, let me show you. Half AT square, and the T we must substitute as 2 V naught by A whole square, which is 4 V naught square by A by 2 into A square, which is same as 2 V naught square by A. So this is the chasing distance. And to catch the thief, the chasing distance turns out to be 2 V naught square by A. Is this clear?
Yes, sir.
Okay. So let's say there are two racers. And they have two different bikes. So the first one is driving their bike, the other is driving. So normally on highway, when two bikers are driving, riding their bike, when the rear will chase or will go past the first will get motivated and he will also start accelerating. So let's say a bike called maybe Avenger is coming from behind and it just passes a bike which is a super bike, Hayabusa. Now Hayabusa will take this on ego and will start accelerating, and you know that Hayabusa will have much more acceleration than the Avenger. So eventually who will win? Eventually, which bike is going to win the race? The bike with greater velocity in the beginning or greater acceleration?
Greater acceleration.
Because greater acceleration means eventually you will exceed everyone, right? So that is the situation, that there are two bikes. So the first one is moving with velocity u1, and u2, let's say u2, the u1 is less than u2. So the bike with lesser acceleration is actually moving faster and you just go past. But u2 can accelerate with a2, but u1 can accelerate with a. Okay. So what I have given, u1 is less than u2, but a1 is more than a2. So who will be the winner again? The a1 will be the winner, right? Because the more acceleration means eventually you can attain the greater speed. But right now, at this point, who will go ahead? The one with greater velocity. So u2 will go ahead, and now both will accelerate. So now here the situation is that both realize that they are going to race. So both start accelerating their bike. But because a1 is bigger, eventually a1 will catch the a2. And the question is same. What is the DCH? So when they will be again at the same coordinate, on a horizontal coordinate, tell me guys, what is the chasing distance? So I hope you have understood the method. What to be done first? First, find the time at which they meet. So the rule is simple. First, you calculate after what time they are going to meet again. So to meet again, they must have the same position. And because they started at the same position and they are ending at the same position, so we can say they must have the same displacement. So you can apply the formula and tell me the answer. Everyone, please. Tell me the answer, guys.
So this the second vehicle is not accelerating. No?
No, both are accelerating. Now A1, A2 both is given.
Achha, okay.
For every chasing problem, what you are supposed to write? The position. And now because the displacement and position are matching in this case, because you start at same point, you end at same point, so you must have the same displacement. So just write S1 equals to S2, write the formula and get your answer. That's it. Is this clear?
Yes, sir.
Okay. So what is the time coming here? If you solve this equation, what is the time T is coming?
So time is 2 into U2 minus U1 by A1 minus A2.
That's it. So once you get the T, can you find the chasing distance?
Yes.
Use any one formula, U1T plus half A1T square. Just substitute the T in the formula and simplify this till the answer. Do it, everyone. So Prashansa and Sila, tell me, are you guys getting it?
So can you please explain again how you got the time?
See, you have to just write the displacement. So because both are accelerating, can you write the formula of displacement in terms of uniform acceleration? S equals to UT
UT
plus
plus
half.
half AT square.
So simply substitute and solve it. You will get the answer. Just a moment. Okay, so you got the answer T. If you guys have the doubt, let me know. I'll explain one second. See, for every meeting problem, there is simple rule. You have to equate the coordinate, and here the coordinate is what? Coordinate means where you are. So you can express that answer in terms of displacement, and that is how you can get the. Because when someone will meet, they are at the same position, right?
So I'm getting the answer as 2 into U2 minus U1 into U2 A1 minus U1 A2 by A1 minus A2 whole square.
Something really bad, huh?
Yeah.
So anyway, whatever it is, you can write it down. So these are some of the typical chasing problem which you will come across in under the motion in one dimension. So basically, these questions we can also solve using the idea of relative motion, but that is a thing which we'll discuss as a separate called relative motion chapter, which is of course part of kinematics, but what we call is kinematics 2. Okay. So we are learning kinematics 1, in which we talk about the one-dimensional motion. In kinematics 2, we'll talk about the two-dimensional motion, especially the projectile and relative comes in that part. So so we'll talk about something very interesting called the reaction time, which we generally represent by the symbol tau, and stopping distance. So again, this is pertaining to the driving situation. So when you are driving on a road, you see something as obstacle, which is like a realization. So first you realize, so there's something called reaction time. You react to the situation in some time, and once your brain has analyzed the situation, it will start giving you signal to apply the brake. So your thinking is faster than your action. Okay. It means the moment you think about something and the moment you actually put your body into action, there is a delay, and this delay is called reaction time. Do you realize this, what I'm saying? So
Yes.
first you think of applying brake, and then you apply brake. There is a gap, although very small, maybe 1 second, maybe 1/2 second. Okay, but there is always a gap. This is small gap, although do not matter for our day-to-day life activity, but imagine the response time of those drivers who are racing on track, or think of the reaction time for the F1, sorry, the fighter pilots. If the fighter planes are moving at a speed of sound, maybe more than that, imagine if your speed is 330 meters per second, a reaction time of half second will let you move by 165 meter, right? No, it's 330 by 165 meter. So roughly you travel 165 meter before you actually think of doing something. So there the reaction time is very, very important, and those who are fighter pilots, their reaction time is actually less than 1/10th of a second. So their recruitment is based on the reaction time, the alertness. So they have to be very precise in terms of reacting, thinking and reacting in the reality. Okay, so they think about something and they react in almost no time. So reaction time is time in which the state of motion is maintained. So whatever is the state of motion, if you were moving with constant speed, that is maintained. If you were accelerating, that will remain constant. So we say that reaction time is a time duration in which the physical state of motion remains unchanged. Because in the reaction time, you don't react. You are about to react at the end of reaction time. So at the end of reaction time, the actual action will take place. And when we are driving and there's again situation of collision, so there is an obstacle, maybe some you're moving in on a highway in somewhere in a distant location, and there is a sanctuary, you're passing, the road is passing through sanctuary. You may expect some animal crossing the road, so maybe some deer or maybe elephant or maybe lion. So on Indian roads this has happened, isn't it? Many times they cross the railway crossing, and you must have heard about the accident of train with elephants in some sanctuary. So the railway lines are passing through some eco-sensitive zone, and there this kind of collision has happened in the past. So the whole idea is to prevent such accident or collision, the reaction time should be as small as possible. So here, what we are going to discuss is that you react for some time and then you apply the brake and eventually come to rest. So the total distance, the distance you travel during the reaction time plus the braking distance. So when you add the reaction and the distance traveled in the reaction time with braking distance, the sum is called stopping distance. Okay. So we have discussed about the braking distance, right? When you apply the brake, how much you travel before you come to rest. So we have to add the braking distance with reaction time, displacement, and addition of the two is called stopping distance. It is clear? So what is reaction time, guys? How to define? So it is the time interval when the driver thinks of applying the brake, but the brakes are actually applied at the end of reaction time. During reaction time, the physical state of motion remains unchanged. So during the reaction time, the physical state of motion remains unchanged. So this is what you need to remember. What is stopping distance, guys? What is stopping distance? Tell me. It is the Siddhant. What is stopping distance? Am I audible, guys?
Yes, sir.
So what is stopping distance? How to define it?
Sir, it is the distance traveled by the body during the reaction time.
And it is the sum of displacement during the reaction time and braking distance. Okay.
Yes, sir.
It is sum of displacement during reaction time and braking distance. So braking distance is when you apply the brake actually, then how much you travel. So stopping distance is displacement in tau plus displacement with retardation. You can think this way or you can write this way. So what I said that during the reaction time, the physical state remains constant. So what is the meaning of physical state? The way you were driving, that will remain unchanged. Okay. So if case one, we take two case one. If the driver was moving with constant speed, if the driver was moving with constant speed, and retardation during the braking was braking is AR. So if you were moving at constant speed, then the S tau will be V naught into tau, because you will continue moving with the same speed till that reaction time. And the braking distance we have calculated, which is V naught square by 2AR, right? If you remember today's lecture, I think here. This was the braking distance, right?
Yes, sir.
So you can do the calculation, but I'm just starting the answer directly. V naught square by 2AR. So the stopping distance we can write as V naught tau plus I hope this is clear to you guys. If not, let me know. Is this clear?
Yes, sir.
Okay. And the case 2 is let U equals to V naught, A equals to A naught. So the initial state is, this is the initial state, and the retardation, I'm just starting in brief. So retardation we are going to assume as AR. So what will be the D stopping, guys? Now your initial state is going to be same for the reaction time tau. So you will travel how much? U tau plus half A naught tau square, because you have initial acceleration also. So you will continue accelerating the car for that duration, because you are going to react only after that, and then you realize, so you will stop the acceleration and will apply the brake. Now, because your reaction time is tau, the moment you're going to apply the brake, what will be your velocity? So velocity, this is again V is the velocity at the end of reaction time. So V naught is the velocity at the beginning of reaction time, and V is the velocity at the end of reaction time, because the braking distance will take care of that velocity which you begin in the braking distance, right? So what will be the V value, guys? How to find V? So which kinematical question we need to use?
U plus AT.
So what is U for this duration?
V naught.
And what is A for this duration?
A
A
naught.
naught.
A naught. So what we should write here? V naught plus
A
A
naught
naught.
T.
A naught
You know, tau.
tau.
Oh, yeah.
Because see, this is the velocity which you have changed during the reaction time itself. And when this velocity has attained by the car, then the brakes has been applied. So the braking distance will take that velocity into consideration, not the V naught, isn't it? Do you realize this? Tell me, guys.
Yes.
Is this clear? So your answer of stopping distance will be is this clear?
Yes, sir.
So with this question, we will complete the uniformly accelerated motion in horizontal plane in one dimension, of course. So the next we are going to start is called the graphical question, like how to use the graph to solve one dimensional question. There are many questions which you can solve, but rather than using the kinematic equation, we will solve using the graphical solution. So we'll plot the graph, and from the graph we'll try to derive the answer, which is much easier than solving manually. Okay. So today I'm going to, okay, I have sent one sheet. I think you all have received kinematics assignment.
Yes, sir.
So have you finished that assignment?
Yes, sir. The first one almost finished. Sir. Only a few questions left.
And Prashansa, you? What about you? And Shreya?
Or I started with the second one.
So you started with the second part. So when you expect it will be over? Before the next lecture?
Yes, sir.
Okay, your next lecture will be on Friday, but it will be slightly earlier. So is it possible for you guys to start at 5:30?
Yes, sir. No problem.
Yes, sir.
Right. So next lecture I'll keep at 5:30. I'll keep it for 5:30 to 8 o'clock, and then you guys will be free. All right. And then the next week will be again holiday because I'm going to my hometown for the festival called Chhat. Once I'll be back, we'll resume the classes, and then probably we'll get no break till January. All right, guys. So see you in the next lecture with a graph. So our next discussion will be graph. And graphs are only plotted for the one-dimensional motion. Okay. So we are going to learn graph in detail. We'll study the simple graph and then complex graph, then very complex graph. And we will also learn that graph is a part of entire physics, and there's certain things about graph that we need to just concentrate on, and then you can solve any question based on graph with ease. So we'll see graph in the next lecture. What is your practice? You can just revise the area under the curve, the integration definition and the meaning of integration, and also revise the geometrical meaning of differentiation. So that is your homework. Revise integration and geometrical meaning of differentiation, because that is what I'm going to use in the graph. Okay. And also finish your assignment as soon as possible, because once you finish, I'll give you the next assignment. In kinematics, you will be solving roughly 3 to 4 assignments because it's a huge chapter. Okay. So bye guys, take care. See you in the next lecture.
Bye, sir. Thank you, sir.